So the trick for finding greatest common factor is just to pick the smallest of the numbers and find that factors for it. So it'd be 1 and 12, 2 and 6, 3 and 4. Notice how I go 1, 2, 3 on this side and then I have the bigger numbers on this side. It just makes it easier for us because if we have it like mix and match, it can be hard. Then we look at the first number, 12. Can 12 go into 60? Yes. Can 12 go into 30? No. So it's out of our factors. Then we go to the next biggest number, 6. Can 6 go into 60? Yes. Can 6 go into 30? Yes. There it is. The next biggest number worked. That's the quickest way to do greatest common factor. So in lesson 2, we're in lesson 2 now. We're looking at 14 on the extra practice. I already have it on the board, so if you don't have it in your book, that's fine. Find the ratio of black cell phone sold to the number of cell phones sold last week. Then explain its meaning. So, how many black cell phone covers were sold that week? How many? Michelle? 4. We can see that because that B right there, it's my terrible chart, but if you have it in your book, it literally says black. That B stands for black. It's 4, exactly. The way we write ratios, we can do a dot dot, or we can do a ratio over. So I'm going to do both so you can see it, right? Now, how many were total sold? How many is the total sold? Lucy? Yes, 18. Exactly. How'd she find that? How did she find that? I want to see new hands. Anita? Yes, she just added all of these numbers together because what does total mean? All. We add all. Total means we add all. So are we done?
No.
Why? I thought we were done. Miles? We need to simplify. So basically when you simplify, you're finding the greatest common factor. But if you're lazy, just keep dividing by whatever numbers pop out at you. You know what I mean? So first, 4 and 18. What's the first number you think of to divide by? 2, right? By the way, that's the greatest common factor. But even if you didn't know that, if there's 2 even numbers, just keep dividing by 2. You know, it's just trying to think, oh, does 4 go into this? Oh, does 6 go into this? It's harder. Just keep dividing by 2. What's 4 divided by 2? What's 4 divided by 2? 2. What's 18 divided by 2? 9. So we would get 2 to 9 or 2 over 9. And what is the meaning of that? I'm not going to write it down, but what is the meaning of that? Somebody, Trey.
2 nines, 2 nines of the
So, what's the meaning of that, Lucy?
2 out of 9 covers overlap.
Exactly. She said it perfectly. 2 out of 9 covers sold were black. 2 out of every 9 covers sold were black. That doesn't mean 2 of the covers were black and 9 of them weren't. Does not mean that. It means 2 out of 9 because this is the part and this is the whole, right? Exactly. This means 2 out of 9. So, Central Sub made 27 sandwiches using 12 pounds of turkey. As I asked before, because I forgot to record, our initial ratio was 27 to 12, or 27 over 12. It says how much turkey was used per sandwich. As Trey nicely answered, per means 1. Which side is our sandwich side, the 27 or the 12? We can say it together. 27. So we want the 27 to equal 1 because that's how many sandwiches. 27 sandwiches down to 1 sandwich. How do we get from 27 to 1? We divide by itself. Exactly. So we divide by 27. Same as if I divided smiley face by smiley face, you get 1. Exactly. So now that I'm here, right, I'm going to divide the other side by 12, right? Because I want to get divided by itself. That's what I want to do. No, that's not what I want to do. What do I want to do, Madison?
You have to divide it by 27.
Why do I have to divide it by 27? That's not itself. Why, Madison?
Because whatever you do to one side, you have to do to the other.
Exactly. Whatever you do to one side, you have to do to the other. Math is always fair. Your parents might favor your sibling more or you more, but math is always fair. In math, what you do to one side, you have to do to the other. And that never changes. In algebra, that's the same thing. In calculus, well, there's not much of same sides, but pretty much the same thing. Whatever you do, you have to do to the same side. So what's 12 divided by 27? First, let's just make it simple for us. 12 divided by 27. When I showed you this divide sign, remember what I told you about the divide sign? What did I tell you about that sign? What is it, Madison? It's basically like a fraction. These dots are just placeholders, right? Those dots are just placeholders until we put the real numbers there. So what number is going to go on the top of this one? What number is going to go on top, Madison?
27.
What do we think? Do we agree with her? 27 goes on the top? 12 goes on the top because we're dividing 12. So 12 goes on the top and 27 goes on the bottom. Awesome. So now we've got 1 to 12 over 27. Am I done?
No.
Ugh, more math? Yes, always. So now, what do I have to do? What do I have to do? Fernando? Simplify. This is another case of finding the greatest common factor. If you don't want to find the greatest common factor, like I said, think of a number that goes into both and then divide. Most of the time, you're going to be right, and it's the greatest common factor. So what number goes into both that we can divide them by, Anita? 3. So, Andrew, what is 12 divided into 3 separate groups? So Andrew said it is 4. Who agrees with him?
Yeah.
Yes, we all agree.
Yeah.
So we're dividing it by 3, right? So then what's 27 divided by 3? What's 27 divided by 3, Hannah?
9.
It is 9. So the answer that we get is in each sandwich, we use 4/9 of a pound of turkey. So our ratio is 1 to 4/9. 1 to 4/9. And the way we would explain it, like I said, is one sandwich has 4/9 of a pound of turkey. Excellent. The results of a car race are shown. Determine who drove the fastest. So our first thought is that Cuthright drove the fastest because look, it took him 84 minutes, right? He beats everybody else, right? But can we just do that? Can we just look at the time and say, oh, that's who did it? No, we have to get them down to unit rates or at least comparable rates. We always have to do that. So we can't just pick the person that had the fastest time because look, all the amount of laps they completed were different, right? All the amount of laps they completed were different. So we have to make them into rates. The initial rate for Cuthright was 35 to 84. The rate for Evans is going to be 42 to 96.6. And then the rate for Loza is going to be 38 to 102.6. Exactly. What we do here is we try to get down to unit rates. We try to simplify as much as we can. So essentially, let's start with Cuthright, right? His is 35 over 84. So let's look at that. That's going to be, I'll make space for each of them, 35 over 84. What can we simplify that to? What can we simplify that to? Can we do that? Ben?
Wait, can't you just divide the both? How long it takes?
Yeah, we can do that too.
It's 7.
Let's do that. Ben wants to do long division. It's probably going to be easier because these ones don't really have greatest common factors. It had 7, 35, and 84. So we divide them by 7, right? What's 35 divided by 7? 5. And then what's 84 divided by 7? 12. Perfect. So this one is at 5/12 so far. We're thinking it's at 5/12 so far. It's a pretty good number to leave it at because we can't go smaller. We can divide. Now here's the thing. If you had wanted to, you could also have written 84 over 35. 5 and divided the time by the number of laps. The only thing that you need to always do is keep the same units in the same place. So see how we decided laps is going above time? So for the next person, can I put time above laps? No, I have to keep going with laps above time. So we see Evans has 42 over 96.6. So it's 42 over 96.6. Now, do we know the greatest common factor? I don't, but they're both even, right? Let's just divide them by 2 and see what we get. What's 42 divided by 2?
84.
Divided by 2. Jaden. No, you're so close though. What's 42 divided by 2? Malia. I'm sure it is.
They can both be divided by 6.
Well, let's just keep, we're going to do it. Hold on. Romario. 21. And what's 96.6 divided? We can start from this end. What's 0.6 divided by 2? What is it? Romario. 0.6 divided by 2. 0.3, exactly. And then 6 divided by 2 is 3. And 9 divided in half is going to be 45. So we have to combine those, and it becomes 48.3. Exactly. Are these even, both of them? Yes or no? No. So we have to think. These factors, 21 only has 4 factors. It's got 1 in itself, and then it's got 3 and 7. So, can 7 go into 48.3? Doesn't look like it. So let's try dividing it by 3. What's 21 divided by 3? It's the other factor. 7. What's 48 divided by 3? What's 48 divided into 3 groups? Fernando?
16.
I think so. Oh. Anyone else have any? And then what's 0.3 divided by 3? 0.1. Exactly. So now for this one, we've got 7 over 16.1. Can we get any smaller? No, we can't. So our last guy, 38 over 102.6. So he is 38 over 102.6. Exactly. You guys can, once again, we can think of the greatest common factors if we want, but if we're lazy, we just divide by 2. What's 38 divided by 2? What is it?
19.
Let's see, who says Matthew? 19. Exactly. What's 102.6 divided by 2? What's 100 divided by 2 first? What's 100 divided by 2? Jaden. So it's going to be 50. Then what's 2 divided by 2? Raphael. 1. And then what's 0.6 divided by 2? 0.3. So we add them together and we get 51.3, right? Can we divide this by anything else? Can we? We can't go any smaller. So these are our numbers. Now, these are really difficult to look at because they're all different units, right? Like the bottom is 12, the bottom is 16.1, and the bottom is 51.3. But what we can do is our butterfly math, right?
No.
Yes, it works. It works. So let's compare the 5 over 12 to the 7 over 16.1 to the 7 over 0.1. So let's think about this, right? And we don't even have to necessarily do the full butterfly math. We just have to think about it. What do you think is going to be bigger? 12 times 7 or 16.1 times 5? What's 12 times 7? What's 12 times 7, Rafi? 84. So this number is going to be 84. What's 5 times 16? What's 5 times 16? Yes? Yeah, it's 80, so this becomes 80.5. Which one's bigger? 84 is bigger. So far, Evans is bigger. He lost. This guy's out. This guy's out. So, now, we're going to compare Evans to Lozo or whatever. Loza. So now we have 7 over 16.1, and we're comparing that one to 19 over 51.3. So we're comparing it to 19 over 51.3, right? Just by looking at this one, without even doing much math, Which one do we think is going to be bigger? Just by looking at this one. No, remember, we're doing butterfly math. So, do we think that 7 times 15, or 7 times 51.3 is going to be bigger than 16.1 times 19? Yeah, because 51.3, that's really, really big. Like, that's so far big that it doesn't even, like, we don't even need to do the calculations. We can just guess. And it makes sense. The answer is 7 over 16.1. So who drove the fastest? Evans. Also, here's my trick. Let's look at my trick. So, Cutright drove 35 laps, and Loza drove 38 laps. Those are pretty close in laps, right? It's only 3 laps apart. But look at how far apart their time was. Look at how far apart that time was. That's 18 minutes apart. That's 18 minutes. Yeah. So it's 18 minutes. That's a lot. So, and it's not 6 seconds, it's 0.6 minutes, which is different. But anyway, so what could we do here if we just looked and did common sense? The 35 and 84 versus the 38 and 102.6. What could we do there just by looking at those numbers? Miles?
Eliminate Loza.
Yeah, we can eliminate Loza. So, we can eliminate Loza. Because his time is just far too much already, which leaves us with only 2 things to work with. Doesn't that make it so much easier? Now we don't have to simplify this one. We don't even have to deal with it anymore. We don't even have to look at it. Now we only had these 2 to look at, right? Here's my other trick. Are you ready? So, if we look at this, 7 over 16.1, right? 7 over 16.1. Is that more than half or less than half? It's less than half, right? By 1. And it's got a bigger number at the bottom. What about 5 over 12? Is it more than half or less than half? Less than half by 1 also. But that means that it's 1 over 12 versus 1 over 16.1. Which one is the smaller number for these ones? Because this means faster, actually, in this case. Yes?
1 over 16.1.
Exactly. That's the smaller. It means it's going faster in this specific case. Exactly. So that's my trick for lesson 3 for rates. As Ben pointed out, long division would work as well. So if we had the 35 and the however much time it was, I think it was like 84 or whatever, we could just long divide it. And I think that we would get like 2 point something or whatever. Whatever we get, doesn't matter. Yes, you can long divide. It's the same thing as simplifying fractions. It's all dividing, right? Yeah, so you can do it however you want. So here is our ratio table. Lesson 4 is about ratio tables. What this means is we have to fill out. We're making equivalent fractions. All we want to do is make equivalent fractions. There's several ways we can do this. Basically, one way is that we can get down to the unit rate if we so chose. And the other way is just to go down to the greatest common factor. I'm going to show you both ways. So, we're going to go down to a unit rate first. So we want it to be 1. How do we get from 16 to 1? How do we do that? Michelle? Divide by 16. So I'm going to divide this one by 16. Same on both sides. Oops, I wrote 12. So I'm going to divide that by 16 as well. What's 16 divided by 16? 1. Who can tell me what 80 divided by 16 is, Rafi? 5, exactly. I know we're going fast for a lot of people, but watch this tonight and slow it down, pause, think about it, do stuff like that. That's not important. Awesome. So it's 1/5. Now, how do we go from 1 to 12? How do we go from 1 to 12? Anita? Times 12. So what do I do to the bottom one? Times 12. Times 12. Same thing, top and bottom. What's 5 times 12, Madison? 60. So our ratio becomes 12 over 60. However, there's another way we could do it. Both ways work. So do whichever way you feel most confident with. The second way is to pick the greatest common factor. What's the greatest common factor between 16 and 12? Greatest common factor between 16 and 12. Gore. 4. So we're going to go down to 4. How do we get from 16 to 4? Michelle said divide by 4. And then I'm just being preemptive. How do we get from 4 to 12? What do we do? Madison? Times 3. So what we're going to do is we're going to divide this by 4 and then multiply that number by 3. What's 80 divided into 4 groups? 80 divided into 4 groups, Fernando. 20. What's 20 times 3, Madison? 60. Exactly. This is exactly the same thing. So if you feel more comfortable doing unit rates, do unit rates. If you feel more comfortable doing greatest common factor, do greatest common factor. Either way works. This is called, and what is this called? Who knows what this is called when we do it like this? Do you remember? Who remembers? Madison? It is right. These are ratio tables, but when we have to do these certain things, when we do this, so when you're multiplying or dividing two related quantities by the same number, it's called scaling. Scaling. It's because we're going to scale it down, but it's staying in the same ratio, and then we scale it up. So 16 over 80, is that equal to 1/5? Yes, because that was the unit rate. 4 over 20, is that equal to 1/5? Yes. 12 over 60, is that equal to 1/5? Yes, these are all equivalent ratios. If you want to check, do that butterfly math. You know, you want to make sure that they're equal. If you don't want to check, whatever. Fenton is building a model of a living room. The model sofa is 16 inches long and 7 inches deep. So it's 7 inches deep. The real sofa that he's modeling it on, the real sofa's dimensions are 80 inches long and 35 inches deep. So what's the initial ratio for our model sofa? What's the initial ratio for our model sofa? Who can tell me, raising their hands? Let's see. Fernando. 16 to 7. And Lucy, what's the ratio for the real sofa's tables? What's the ratio for the real sofa's table? Or tables. I'm just speaking. The real sofa. Whatever. It's exactly 80 to 35. Great job. Now, one thing we can do here is, can we just keep dividing by 2? Can we? No, because one of the numbers is odd, so we can't do that. We can't use our cheat method. We actually have to sort of think about things. Now, 80 to 16. We did that before. How do we get from 16 to 80? How do we get from 16 to 80? What do we do? Jenna? Times 5, right? Times 5. So we're going to do the same to the 7 and hope that it works. Is 7 times 5 35? Yes. So are these ratios equivalent? Yes, exactly. Now, what if I had a different ratio, right? What if I had this one? I had 16 to 9, and I had 80 to 50, right? So I had 16 to 9 and 80 to 50. Once again, how do we go from 16 to 80? We already said it. How do we go from 16 to 80? Jaden? Times 5. So we did it times 5. If you're thinking about it dividing by 5, it's the same thing. We would divide by 5 from 80 to 16. Do you see how they're opposites? It still works both. So then we have to do the same to the other side. What's 9 times 5? Who can tell me 9 times 5? Fernando? 45. So is 45 equal to 50? No. So are these two ratios equivalent? No, they are not equivalent. That's how you determine if ratios are equivalent or not. This is important. For a store contest, 4 out of every 65 people who visit the store will receive a free DVD. So, how many people receive the free DVD? Fernando? 4. And how many people are in the store total? Daniel? How many people are in the store total? Who knows? Jaden? How many people are in the store total? Malia?
455.
No, right now. For the ratio, for this ratio. 65, yes. So our initial ratio is 4 to 65. But we want to see if the store had 455 people total, right? So we want to go from 65 to 455. I'm going to give you guys a chance to figure that out. So how do we get from 65 to 455? How do we do it, Nathan?
I multiply 65 times 7.
Times 7. So what do we do to the other side? We multiply it by, Rafi? 7. Same on both sides. Who can tell me what 4 times 7 is? What's 4 times 7? Raphael? 28. So if 455 people visit the store, how many DVDs were given away, Lucy? 28 DVDs were given away. Exactly. So in this case, you have to pay attention. We're not trying to make a unit rate in this case. We're not trying to make a unit rate. We're trying to make it so that it corresponds directly with how many people are in said store. So here, there are 2 employees for every tiger in the tiger exhibit at a local zoo, right? So if I have 1 tiger, how many employees do I have? Rafi? 2. Oops. If I have 2. If I have 2 tigers, how many employees do I have? Anita? 4. If I have 3 employees, how many do I have? Jaden? 6. And if I have 4 employees, how many do I have? How many do I have, Newham Fernando? 8. Super easy. So what would our coordinate points be? What would our coordinate points be? Who can tell me? Jaden, give me them for the first one. What? 1, 2. Exactly. What about for the second one? Who can tell me the second one? Who can tell me? Let's see. Romario. 2, 4. As such, it's 3, 6, and 4, 8. Exactly. Notice all of these fractions are equal to 1/2. Notice all of them are equal to 1/2. They're equivalent ratios. That's how these need to be. Now, for every elephant in the zoo, there are 4 employees. So on the other side, with 1 elephant, how many employees? 4. With 2, 8. 3, 12. 4, 16. So as such, our plot points would be 1, 4, I'm not going to write the parentheses, 2, 8, 3, 12, and 4, 16. And again, these are all equal to 1/4. So these ones are all equal to 1/4. Now, I want you guys to tell me, and this is so easy. So when we graph the ordered pairs, which one is going to have a steeper slope? Which one is going to have a steeper slope? Which one? What do we say? Who raised their hand and said this? Trey? Elephants. Why do you say elephants are going to have the steeper slope? Because there's more elephants? We have the same amount of elephants. There's more employees. Exactly. So if we went to the next page, if we were doing it, I'll show you the answer just so that we can get it over with. There, it's coming. So our answer is this. Which one has the steeper slope? Elephants. Exactly. And the tigers are like that. Once again, notice how they start really close to one another, but as time goes on, they keep getting further and further. Also, just a question. What is this point called right here? Right there. Who can tell me, Miles? Origin. Exactly, because everything originates from there. It's 0, 0. You guys did a great job. Excellent.